So you have reached the end of the essentials for quadratics, and we're going to begin the extensions. There's a number of different extensions, but the first one is to talk about why do we really care about solving roots for quadratic functions and why does it matter? And there's a number of different applications. One of the main ones is projectile motion. So when something is being thrown or being shot into the air, they all are modeled by quadratic functions, and so you can use quadratic functions to model real-life situations and then figure out things like what's the maximum height of your bullet or your basketball or your football or your soccer ball or whatever you happen to be kicking or throwing. In this situation in front of us, it's a flare. We can figure things out like how high is it going to go, when is it going to reach a certain height, those kind of things. And so here's the first question. It says a flare is often used, and these are in your essentials booklet, or your extension booklet, sorry. So we're just going to go through a few examples, and then you're going to have time to work on them on your own. But this one says a flare is often used as a signal to attract rescue personnel in an emergency. And when a flare is shot in the air, this is the function that models it. So you've got a height, and you've got it with a time. Minus 5t squared plus 40t, and that's the height. So it's at what time or times, you notice there's an s there because it's saying it could be 2, is this thing going to have a height of 50 meters? So what we do is this just becomes our h of t. Okay, so we go 50 equals minus 5t squared plus 40t. And then what you have is a quadratic function, or a quadratic equation. So what we're going to do is we're going to take everything over there to make it so that it's equal to 0. So we have 5t squared minus 40t plus 50 is equal to 0. And then you guys have solved these. You should know how to solve a quadratic equation, and you have a couple of options. You have factoring and you have the quadratic formula. I'm noticing right away that there's a common factor of 5 in each of these, so I'm going to take that 5 out of there. So 40 divided by 5 is 8, and 50 divided by 5 is 10. All right, so I get this. And then since 0 divided by 5, if I divide both of these by 5 and divide 5 here and divide 5 here, I end up with this equation. T squared minus 8t plus 10 is equal to 0. And then I'm going to try to factor that if I can. So I need 2 factors of 10 that add to give me 8, negative 8. And that's not really possible because the only factors of 10 are 1 and 10 or 2 and 5. And neither of those two are going to give me 8. So that means to solve this, I'm going to use the quadratic formula. All right. And that is going to be, in this case, t is minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So this is our a is 1 here because it's in front of the t squared. Our b is minus 8 and our c is 10. So we're going to plug them in. So we get 8. It's minus b plus or minus, and then minus 8 squared minus 4 times 1 times 10. And that's all divided by 2 times 1. Oops, I want to write the a there, sorry. So then I'm going to figure out what that discriminant, that b squared minus 4ac thing is. What is this? So I have 8 plus or minus the square root of 64 minus 40 divided by 2. And so I end up with 8 plus or minus the square root of 24 divided by 2. All right. And then at that point, we're going to split this into 2 possibilities. We're going to have 8 plus the square root of 24 divided by 2. And we're going to have 8 minus the square root of 24 divided by 2. And then we're going to grab our calculators, and we're going to ask the calculator to tell us what the square root of 24 is, because it's not a nice perfect square. it's close to 5, right? Square root of 25 is 5. So if we put 24 in and take the square root, it gives us 4.9, I'm going to say. So we're going to go 8 plus 4.9 divided by 2, and 8 minus 4.9 divided by 2. And if we continue down, that is going to give me 12.9 divided by 2, and this is going to give me 3.1 divided by 2. And so I kind of keep my equal sign along here. T is going to equal down here, whatever 12.9 divided by 2 is, and that's 6.45. And then 3.1 divided by 2 is 1.505, so 1.51. So those are our two answers. I'm going to go 1.05. Okay, and that's in seconds, I believe. We check our question again. It says the time is in seconds. Yep. And they both work because time can be only positive, but they are both positive in this case. So that's how you solve a quadratic equation. You guys are used to doing that, but that's how you do it in a context of a actual scenario. All right, here's another example. Again, these are from your extensions sheet. This one says a football player is throwing a football into the air, and this is what it's modeled by as a function of time. And it says, when is this football going to reach 20 feet? So we're going to go, again, that 20 feet is going to become our height, and we're going to have minus 5t squared plus 24t plus 1. So we're going to bring everything over. Okay, and you can also, the other option is to bring the 20 that way, but the reason I'm doing it this way is because there's a negative in front of the t squared. So if I bring it over there, it becomes positive, and I like positive numbers in front of my t squareds. It's entirely up to you. You don't have to do that. I just find it helps. So there's my equation, and then I'm going to get 5t squared minus 24t plus 19 is equal to 0. And at that point, I try to factor if I can, because factoring is quicker, but I can't factor this because 19 and 5 don't have a common factor, so I can't take out a common factor. I can't directly factor because of that 5, but I could do slide and divide and see if that works. So we can check what's 5 times 19. So we go 5 times 19 is 95, and I need to find two numbers that multiply to give me 95 and add to give me 24. And that's not likely to happen. So I'm going to just use the quadratic formula again. So I'm going to go t is equal to, in this case, b is minus 24, so I get 24 plus or minus the square root of minus 24 all squared minus 4 times a, which is 5, times c, which is 19. And we're going to divide by 2 times 5. So 24 stays there. 24 squared is a rather large number. So we can go 24 times 24 is 576. That's that one. And then 4 times 5 times 19 is 380. And it's all divided by 10. So I'm going to end up with 24 plus or minus the square root of whatever 576 minus 380 is. So it's 196 divided by 10. The square root of 196, I'm going to ask that, and it's 14. So I get 24 plus 14 plus or minus 14 divided by 10. So that gives me two options. It gives me 24 plus 14 divided by 10. And that's 28 divided by 10, which is 2.8. Or I get 24 minus 14 divided by 10. And that gives me 10 divided by 10, which is 1.0 seconds. So those are my two options. When I get numbers like that, in other words, when I get a square root that works nicely, then I know it would have factored had I done it that way, but I decided not to because I wasn't getting answers really quickly. So that's the idea. Here's another example. This one's slightly different. It says Alex sells lawn ornaments And his profits are expressed by this equation. They're represented by this equation, where N is the number of ornaments that he sells, and P is the profit. But it's a profit in hundreds of dollars. So if it says if Alex wants to make a profit of $800, how many ornaments does he have to sell? So it says Pn equals 8. So we go 8 equals minus 0.04 n squared plus 2n minus 6. And again, I'm going to bring everything over that way because I like having a nice positive number in front of my n squared. It doesn't make a difference really. I just like to do it that way. So I'm going to have plus 6 minus 8 equals 0. So that's going to give me 0.04 n squared minus 2n minus 2 is equal to 0. All right. And what you can do, if you want to try to make this not using the quadratic formula or try to factor it, there is a common factor of 2 in each term. You also, if you want to get rid of the 0.0 thing, could multiply the whole thing by 100. So it's up to you how you solve it. I'm going to, for sake of time, just say that n is going to be this quadratic formula again. So 2 plus or minus the square root of minus 2 squared minus 4 times 0.04 times minus 2, all divided by 2 times 0.04. And I will leave you to solve that. I think you're all capable of doing that. But that's how you would set it up. The next part of the question says, how many ornaments does he have to sell in order to break even? So if he breaks even, his profit is 0. So we'd say 0 is 0.04 n squared, negative, sorry, 0.04 n squared plus 2n minus 6. And then again, you would solve that using the quadratic formula. So your quadratic formula this time would be n is minus 2 plus or minus the square root of, and then 2 squared minus 4 times negative 0.04 times minus 6, all divided by 2 times negative 0.04. Okay, and if you're careful with your negatives, you can solve that out. Again, I'm pushing the time limit, so I'm not going to solve that, but you will get 2 answers, generally speaking, and one of them will probably be negative, and if that happens, then you can't sell a negative number of ornaments. All right, so that's how you do quadratic applications problem. There's more in your booklet.